Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Today I'm going to slightly switch over the topic. I'm going to go into stability again. Let me do a quick module on center of gravity. It's a very important concept, very basic concept. This uh, concept of gravity does not start only in shipping. Please remember it was there in your school time also. So it was one of the topics in your physics. So what we have done is we have extended that concept into the ships and stability of the ships also. Principle remains same. We just use it for an object which is floating. Otherwise, if you see, the word center of gravity is valid for every object on the earth. So let us have a look on this topic and understand the concept. Let me just start off with a few points on the basic definition or some sentences which can make you understand what exactly you need to know about gravity, which is related to our shipping industry. All of them are borrowed from physics, as I said. So if you look at the basics of Earth, we all know Earth attracts all the objects towards the center, which also means that these objects which are attracted, they are attracted by a force of gravity. And that force of gravity takes you towards the center of the earth, which again, in a small change in the words, the weight of an object is also the force with which it gets attracted towards the earth because of gravity. And we all know that every object has got a weight. Now, that is a whole concept. If you remember why we are standing on the ground, we are not trying to float off in the air because of loss of gravity, which you can see in artificial satellites or space centers. Now, how does this whole phenomena is used in shipping to understand the whole stability of it? I need to slightly split it again, this center of gravity. What do you mean by center of gravity? And that is born out of this force acting towards the center of the earth. You all know that objects are made of a lot of particles, millions of particles, if we can call it. Now, each particle, please remember, is being attracted by a force due to gravity towards the Earth's center. So each particle is being attracted. Now, when I say you have so many particles in an object, if I start looking into each particle, it makes our life a little bit miserable. So we modify it slightly. We try to replace it with a single force. And let us see what is that single force. That single force or a single point, I can call it center of gravity. I've used the word that it is an imaginary point. A lot of books use the word called assumed point also. You can take anything, whatever it means. I have a reason why I put imaginary point. Let me show you some examples, and you'll understand why I said imaginary point. So I can call it a point or an imaginary point or an assumed point through which the full force of gravity of that object, again, even though each particle is being attracted, right now I'm changing it to a single force. So it is a point through which that single force of gravity or the weight, which is again, weight is also a force of the whole object, can be considered to be acting vertically down towards the center of the earth. So gravity always acts vertically down towards the center of the earth, wherever you're standing. It doesn't matter. As far as you're on the earth, it will be similar. It'll be just only thing is you'll be at different places, but still doesn't matter. Now let me show you two pictures where on the left hand side I've shown you a picture which is showing me athwartship. So let us consider I'm looking from stern to a ship. So I've shown you port and starboard. Then I've shown you a partial three-dimensional diagram where I've shown you the aft and the forward part, because we need to understand the gravity in all the dimensions. So let us quickly have a look. Let us imagine this was the center of gravity when we looked from stern in an athwartship direction. So this point obviously is going to act vertically downwards towards the center of the earth. So this is that single imaginary point. Even though ship has got a lot of weights, I consider this as a point where I can assume that my whole body's weight is acting vertically downwards from this point. The same point, if I try to show you in a three-dimensional diagram, it could be somewhere here. This is all examples, so it could be somewhere here. And even this one is going to act vertically down. Wherever I show, it will be vertically down. Now, this position of center of gravity, as far as our shipping is concerned, I'm interested to locate it. So how do I locate it? I can indicate it by distance from three reference locations, which are very commonly used in our industry. So let us see what are those three locations for me to reference and mention where the center of gravity is located of your ship. The first one is from keel and is measured upwards. So I've shown you on the left-hand side diagram. I'm going to show you that. So you will see there is a keel. I'll again show you. See, this is a keel, and this is the vertical distance from the keel to center of gravity. So since it's a vertical direction, so I can call kg or VCG also, which is your vertical center of gravity. Same thing I'm going to show you on the right side picture also. Please see K as the keel. I can measure it from the keel, and kg and VCG are same. What is the importance of kg and VCG? Your kg or VCG affects the stability of the ship. So is one of the most important concept and the character in your stability part of it. Okay. Let us look at the second reference point. The second reference point is the aft perpendicular, and it is measured always forward. So let me consider this as the aft perpendicular. You can see on the second right side diagram, aft perpendicular. It is called AG also, but more popularly, it is referenced as LCG. You will see when you talk about stability in books and solve and all, it is 99% called as LCG. Some of the books still call it AG, but it's okay. So LCG is more common word. Now, if I measure forward from aft perpendicular, you can see I've shown you in the green color arrow. This is what is your LCG. Alternately, I can measure the center of gravity from midship also. The word midship, we have already seen in the definitions earlier. It is midway between your aft and forward perpendicular. So let me show that as an H. So this is your midship. I can measure it from here as well. And this is what is called your HG. So what is the importance of LCG? LCG affects the trim of the ship. Later on, I'll show you with small diagrams. So LCG affects the trim of the ship. Let us go to the third reference point. Third reference point is measured, or the reference point is the center line, and I measure the center of gravity from the center line. So either it is on the port side of the center line or starboard side. Please look at the second, which is the right side diagram. I've just shown you a center line. This is not very clear, so I'm going to show you a plan of a ship. So I'm going to create a plan of a ship. I can call this as the center line. And let me say my center of gravity was somewhere here. So you can measure it from the center line. And this reference point gives me an indication of list. So we have seen the three different dimensions of measurement of center of gravity. One was vertical, which affects the stability of the ship. The second one was LCG, which will affect the trim of the ship. The third one was from center line, which will affect your list of the ship. Okay. Now, one of the most important note you have to remember in all your center of gravity calculations is the position of center of gravity depends only on the distribution of weights. It does not depend on the total weight, which clearly means that I can give two people two ships which are exactly the same, and I can give them 10 containers each, which are exactly the same, and tell them to load. You will see each one of them will load differently. The final displacement is going to be the same for the vessel, but the position of center of gravity need not be same because both of them would have loaded differently. So that is why this is very, very important that COG is dependent on distribution of weight. Let me just put it in one more phrase. Center of gravity can also be called as a geometric center of the distribution of weights within the object. So you have a ship, you have distributed the weights. How you have distributed will govern the geometric center of the weights, and I can say the geometric center of the weights can also be called a center of gravity. For a common man, these two sentences are good enough for you to understand how to locate the position of center of gravity. Now I'm going to show you some figures, different figures, just to justify the word. I had used the word called imaginary point. So let me show you a small ring. It could be a ring which you wear on your fingers also, or it could be any metal ring also. If this ring is made up of, let us say, steel, silver, whatever it is, you will see because of the shape, the center of gravity is going to be at this imaginary point, which is called center. And you should realize at the center, there is no object. You can see there is no object. So that means the center of gravity need not be on the object itself. It can be out of the object also. It can be within the object, it can be outside the object. So it's very important, please remember this. Center of gravity need not be on the object. Now I'm changing the shape. Let me just put it a kind of a square object. So if this square object, since it is square, I can consider it here. Let me change the object. Let us say it is a hollow square. It is not a solid square, it is a hollow square. You will see even now it will be here. Again, it is not on the body itself, it's somewhere which is not on the body. As an example, I can just quickly show you. Let us take a small table. There is a center of gravity of this table also. And if you calculate, there is a high possibility that the center of gravity could be here. So this is the reason I'm trying to use the word imaginary point, because it is not located physically on the object. That is the reason. Now, if I give you a solid cube, 100% is going to be at the center because, let us say, solid cube is uniformly distributed in the weights. So these are few examples which are trying to tell you that how you can locate the center of gravity. Let us go further on this. Let us try to understand the importance of center of gravity. If the center of gravity is exactly on the center line, that means it is neither port nor starboard, then your vessel is going to be upright and you will not have a list. I'm just trying to show you again an athwartship picture looking from aft. So if your center of gravity is exactly at the center line, you will not have a list. But the moment you change this, you will see if this is the condition of center of gravity, since I've shifted it more to starboard, then you'll have a list. So your center of gravity will always lean towards the heavier side of the ship. It will always be towards the heavier side of the ship. Similarly, let me take a rectangular, a box-shaped vessel only. And if I have my center of gravity exactly at the midship, you can expect this vessel will be even keel without any trim. But if I change it, let us say I moved it aft, so I'm getting a trim by stern. So this is how the change in the center of gravity affects various factors in your ship, which we have seen. The main three important things are stability, trim, and your list also. I have not used a ship shape because ship shape is a little bit complicated. So I will leave it for now. That will be dealt when we talk about trim. There we use more of moments. So I'm not going to talk about it. Now let us see how the center of gravity changes whenever we add a weight, we discharge a weight, or we shift a weight. Let us see what happens in these three conditions. My cargo operations on board involves these three. So all you can do is add, subtract, or shift. So let us quickly look one by one case. I'm giving you an initial condition where on the left-hand side picture, let us say my vessel was already in this condition. I had the center of gravity at G, acting vertically downwards towards the center of the earth. And this original G can also be given a kg because it is vertical center of gravity. So let us quickly have a look. Let me add a weight. The moment I add a weight here, you should realize by the concept, the place where I've added the weight becomes slightly heavier than the rest of the places. And we already said center of gravity always will go towards the heavier part of the ship. So if you look at a simple concept, I can just join a line between the original center of gravity and this weight loaded, and this G will move towards the weight you have loaded. It may reach a new point, and I can call that G1. And again, as usual, the center of gravity always has to act vertically downwards. So this new G1 can also be called as KG1 because you have added one cargo. It will act vertically downwards. Now, I have shown you this in a two-dimensional diagram. I'll be translating this into three-dimensional diagram also. And let us see how things vary. But before that, let me just give you a couple of more addition of weights. And you see how the weight keeps changing when you are doing a cargo operation. Let us say you are loading. Now I'm going to start the second picture from G1. Okay. So let me say this is the present condition for me. And now I have loaded here one more cargo. So that means this place becomes more heavier. So the G will directly go towards the weight to a new point called G2. And again is going to act vertically downwards. Let us take a third weight. Now this is G2. I'm taking a third weight, let us say here. And again, this bottom port side portion will become heavier. So the G is going to shift directly towards the weight. I'm going to G3 and again here. And this goes on for all your loading operations. You can see now again, it will go here to G4. Then again, let us add one more. I'm sorry. Okay, that was G4. So what you realize from this picture is, as and when you keep loading on the ship, the total displacement of the ship keeps increasing slowly, but the position of center of gravity will always lean towards the heavier part of the ship, the way you have loaded. Okay, let me change to the next operation, which is your discharge operation. Please remember, weight loaded, the place where you loaded the weight becomes heavier. So your G will always try to go towards the heavier position. So that was the first case of loading. Let us do discharge. Please look at the left side picture. I've already given you a weight. It is already existing. I'm going to discharge this weight. You should realize the moment I discharge this weight, the opposite side of this cargo, when you compare with the G, that becomes automatically heavier. So that is why if you want to know where the G is going to shift when you discharge, you should join a line with the cargo and the original G, and you should move the G away from the cargo's direction. So this is where the ship becomes heavier, just because you discharge the weight from, let us say, on the main deck or wherever you discharge. So this is what is going to happen in discharge, exactly opposite of your loading, because every discharge, the opposite side becomes heavier. So let me do a couple of them just like before. So I'm going to give you G1. So this is a KG1. Now let me do a second operation starting from G1. I'm discharging from here. So my G is going to go in the opposite direction of the cargo. It will attain a new position called G2. Let me start with G2. I'm discharging a cargo from here. So G will move away. G3. Let me discharge one from here. It will again move from here. So as we did earlier, during the whole operation of cargo, the center of gravity keeps changing. The total displacement of the ship right now will keep decreasing. And wherever you have discharged the cargo, the COG is going to go exactly opposite. So these are two cases done. Let us look at the third case, which is your shifting of weights. You should realize when you shift weight, the total displacement does not change, but the distribution changes. So of course, center of gravity also will change. So let us quickly look at a position here as alpha. Let me say I shifted to Bravo. The G is going to move parallelly to this shift. So I've attained a new center of gravity called G1. Let us do a second shift from Bravo to Charlie. So from G1, it is going to go parallelly to G2. As and when you keep shifting, that particular portion becomes heavier and heavier. So let me start with G2. Let us say I shifted a cargo like this. So your G also will go parallelly to G3 and so on. So this is how the shift works. Please remember, during the cargo, again, as usual, the center of gravity keeps moving. And I'll show you a couple of more examples just to show you here. Your cargo could have been moved from this place to this place also. Even now, your G is going to shift. You could have moved from here to here also. Even now, the G will shift. You could have moved from here to here also, and still the G will shift. Doesn't matter Where is your A and B? As far as it is shifting, doesn't matter where you shifted from, the G is going to take on a parallel track with wherever you're shifted. The only thing is be careful in shifting operation, the total displacement does not change. Now, what I'm going to do is I'm going to show you a simple operation in all the three dimensions. Why the three dimensions are important? Because every time you make a change in weight, that means a load, discharge, or a shift, your center of gravity is always going to do a three-dimensional change for each and every cargo operation. So let us see all those dimensions. Let us assume that I have a ship already existing with a G here. Now I'm loading one container, let us say on the starboard, on the forward, and up on the main deck. So take this example to understand. Already the G is existing right now here. I'm going to load a container starboard of the center line, forward of, let us say, the midship, just to give you a clue, and on top of the deck. So if I show in two dimensions, I can show you with this diagram. You can see it is starboard, it is on top of the deck, and I will have to show this on the right side 3D diagram. You will see the G is directly going to shift towards this object. Okay. So when it shifts, it'll do three-dimensional change. The first change is a vertical rise because you loaded a cargo above the original G. So I've given that with the blue component, which is the vertical rise. This is your KG1. Now it'll do the second motion in the same operation. Why? Because this cargo was loaded forward. So that means, again, this G would have gone towards the cargo, but then it will have a component which is longitudinal component also, which is marked with green color. So I've shown you right now two components or the two dimensions. So if you go on a gist, first the G raised up, but at the same time G went forward also. I'm going to show you the third component because I told you I've loaded the cargo on the starboard side. So let us look at this third diagram. Let us say that I have loaded the cargo here. This is what is starboard, forward, and on the upper deck, or let us say main deck. So now this G also would have gone towards it, but this time it has the athwartship component also. So now how do I represent all these? Let us quickly see. Every operation, either it can be load or discharge or shifting, is going to change your stability a bit, a trim a bit, and a list a bit. So see here, the first component was the blue, which is vertical, VCG. The second component I showed you was your LCG. And the third component was your transverse shift. So every operation is going to create these changes. But when we start looking at basic stability, and for any beginner, it is very difficult for you to combine all the three together and solve a problem. So what we do is we separate them. We separate them into three dimensions. We will deal one dimension at a time. So for me, the first dimension is your VCG, which is only the blue component. The second dimension could be your list, which is the brown component, is only in transverse. And the third component was your trim, which is longitudinal direction. So when we solve problems in stability, we'll always try to split them into these three components separately and solve. It makes our life easy and we can understand